Hello you guys! Today I'm going to be doing the 2009 number 4 non-calculator AP problem. And what I'm going to be talking about in this video is not only how to solve the problem, but common mistakes and things to watch out for, and also how you can maximize the number of points you receive even when you're confused about how to do the problem. So that's what we're going to be going over today. So question 4 itself has been broken down into 3 parts, A, B, and C, and has given us an area R between the line y equals 2x and the curve y equals x squared. And so it wants us to find the area and also the volume using 2 different cross sections. So it's pretty straightforward, but there are a couple things that can be pretty confusing if you don't watch out for them. So part A is the area problem, where it asks us to find the area of region R. So what we first must do is create the integral and put in our limits from 0 to 2, because the x values 0 to 2 are what borders region R. Second, we have to put in the functions that actually make up the area. So 2x is our upper function because it's above the area, and x squared is our lower function because it's below the area. So you subtract the lower function from the upper function, and then you put in dx with respect to x. Second is you take the antiderivative. So if you look at our first function, it's 2x. So you take the antiderivative, which is x squared, and you subtract from the other function, which creates x cubed over 3. And then you evaluate them at 2 and 0, which basically means you plug them in and you subtract. So if you look right here, plugging in 2, you have 4 minus 8 thirds, because you plug 2 into each of these, subtracted from when you put 0 into both of these, which is just 0, which gives you 4 thirds. So some common mistakes that people make, or things that they don't realize, is that there are only points given for a certain number of things. So it's really important that you include everything so that you're not marked off even though you've done all the work and have the right answer. Remember that it's better to show more work than not show any work at all, because you don't want to miss out on some points that you could have easily gotten. One of the first things to remember is that you always have to write dx. Do not forget it, because you can get points marked off, and you don't want to get those points lost because of something that you just didn't want to write because you felt that you were under a time crunch. Second is that even if you set it up wrong but you still take the antiderivative, you can still get points for that. So it's really important that you show that work. And finally is you get points for the answer, but make sure it's very clear what your answer is, so box it. Don't give them any reason for them to not give you any points. So part C is a volume problem, where it's cross sections, but this time it says another solid has the same base R, but for this solid the cross sections are perpendicular to the y-axis and that they are squares, and it wants us to write but not to evaluate an integral expression for the volume. So what this means is that now we're going to have to put things in terms of y, and that's going to change up our graph. So now our graph is almost rotated, and we're going to have to change our limits and the functions themselves. So now we're going to put things in terms of y and solve for x. So normally we have y equals 2x, but now we have y over 2 is equal to x. And before we had y is equal to x squared, and now we have the square root of y is equal to x. And this is because it's not negative because it's in the positive part of the graph. So here, our limits are changed. So now it's 0 to 4, because if we look at our graph, we have from 0 to 4, and our upper function is the square root of y. So no longer was it this y equals x squared. Now it's our square root of y is equal to x, and now that's our upper function. This is our lower function, and because it is a square cross section, we're going to square it, and technically it's multiplied by 1. And then dy, not dx anymore, because it's in respect to y. So because this is a tricky problem, there's a lot of things that you're going to have to wrap your head around and remember. So first is that you have to put things in terms of y, like you have to change up the function themselves. and that's really important to remember. Because it doesn't want us to evaluate, you have to make sure that you aren't missing anything because all the points are in the setup and the work itself. Second is your limits. You need to put the right limits on there. You can't have the limits in respect to x. You have to change them when you change your functions. Second is that it's not just an area problem, it's volume. So you're going to have to square this because there are cross sections, and make sure that you have all of your cross section formulas memorized. And finally, it's dy. Writing dx, you won't get the point. dy is very important because it's in respect to y, because we're changing everything, our limits, our functions, all in terms of y. Okay, so we've come to the end of our video. I've compiled a list here of some AP problems that you can practice with, and hopefully this has helped you kind of get a better understanding of how to work these AP problems, and more specifically area and cross sections. So thank you for watching.